Hello, my amazing students. This is Mrs. A, and we're doing Category 3, Lesson 6B, which is solving equations by substitution or elimination, but these are not linear equations. These are quadratic being solved with a linear. So we talked about in A, we talked about doing it with just graphs and being able to see the graph and see the solution. Now in B, we're talking about doing it without the graphing. So we're going to practice substitution and elimination where we can. In this case, we're going to use substitution. So here I have a y and a 2y, and I'm going to basically, if I doubled this one, I could set it equal to this one. And that's what I'm going to do. So basically, I will double this whole equation, and I'll get 2y equals 2 times x squared is 2x squared minus 2 times 4x is a minus 8x, and then a 2 times a 4 is 8. So basically, I just doubled the whole equation. So I have a 2y and a 2y. And since 2y equals 2y, I can now set these two quantities equal to each other. So I'm going to set these two equal to each other, which means I set these two equal to each other. So I end up with 2x squared minus 8x plus 8 equals x plus 4. So now I'm going to take this bottom line and simplify it. So I wrote it out again, and then I got everything on one side so that I have a 0 on the other. We always want a quadratic to be set equal to 0. And so now I'm going to say, is there a way that I could factor this in such a way as to get a -9 in the middle? So here we have it. I factored it really quickly. 2x minus 1, x minus 4 equals 0. And now that I've factored it, I have the x values of the solutions. Remember, the solutions are x, y ordered pairs, but this only gives me the x values that are solutions. So when I set this one equal to 0, I get x is 1/2. And when I set this one equal to 0, I get x is 4. So those are the x values. Now I have to go find the y values that go with those x values. In order to do that, I'm going to plug each one of these x's into my linear equation. And then, of course, I will check each solution into my quadratic as well. So it's just easier to put it into the linear equation to find the solution, and then I have to plug them into my quadratic just to check them. So when I plug in a 1/2 here, I get a 1/2 plus a 4 is 2y, so 2y is 4.5. So y is going to be 4.5 over 2, but we usually don't write fractions with decimals in it. So let's just multiply both by 2, and we're going to get 9/4. So that's going to be the y that goes with 1/2. And then we plug in a 4 right there, and we're going to get 2y is 8, or y is 4. Okay, so let's get our points a little clearer now. Okay, so these were the points when I coupled the x and the y together. I've already used my line to get those points, and now I'm going to look at my parabola and just verify that these are going to be actual solutions. So let's plug each one into the parabola, because of course solutions have to make both the line and the parabola true. So if I plug in a 1/2 and I square it, I get a 4th. Minus 4 times a 1/2 is minus a 2, plus a 4 is going to end up being 2 1/4, and 2 1/4 is going to be 9/4, isn't it, when I make it an improper fraction. So we can say that one checks. Now let's plug in the 4 and the 4. So here I plug in the 4, I square it, and I get 16 minus 4 times 4 is 16, plus 4 is 4, and that one is true as well. Therefore, this is verified to be my solution set. And when I look at the book, that one matches, in our book, it matches number C, the answer C. So, in our book, that's the answer. Okay, so but this is how the process goes, being able to find a solution set. Now let's just recap that again because that was a pretty complicated problem. We started with our two equations. One was quadratic, one was linear. And I'm looking to do this with substitution, so I observed that here I had a y and here I had a 2y. And if I just got them the same, I could set them equal to each other. So I multiplied this top equation through by 2, which gave me a 2y, and then this one was already a 2y, so I was able to set these two equal to each other, which I did at the bottom. And I rewrote those here across the top. Now I looked at this. When I simplified it, I got 0 on one side, just like we always want to do when we're solving a quadratic. I was able to factor, set each factor equal to 0. So I was able to get my x values. Quadratics have two solutions, okay, two possible solutions anyway. So we had two x's. And then I took each one of those x's and I plugged the x's into the linear equation to get the y's that resulted when I plugged in those x's. Then, after I got the solution points using the line, I went through and verified with the parabola that they were indeed solutions for the parabola as well. And this was my answer set, and it matched C in my book. All right, so now we are going to algebraically solve this problem. So we're starting out with a y is x squared minus 4. That is an upward facing parabola, and then this one is y is x plus 2, which is a line. So we have an upward facing parabola and a line crossing through it. We're trying to find out where the points of intersection are. So because I have a y equals and a y equals, I can set the two y equals to each other, and then I can set their quantities they stand for equal to each other. So we wind up with x squared minus 4 equals x plus 2, which gets rid of the y's and makes it so that I have an equation that's only in x. So now I'm going to simplify this to get a 0 on one side. So basically this moves over here with a negative, this moves over here with a negative, and I get x squared minus x minus 6 equals 0. Then I factor. This one is an easily factored equation, so I don't have to work on anything but just factoring it. Then I set each factor equal to 0, and I get x is 3 and x is negative 2. Now remember, these factor because they FOIL to give me back. Remember foiling, we multiply these two, we get an x squared. We multiply the outsides and we get a 2x. We get the insides as a negative 3x, and the 2x and the negative 3x give me the negative x, and then the negative 3 times the 2 gives me the negative 6. So here is my answer so far, but I have two x values. I have not yet found the y values. So now I'm going to rewrite this, x is 3 and x is negative 2, but I'm going to put them into my two equations I started with. So here on this board, I have my two equations here, and I have x is 3 and x is negative 2, which I've already discovered. So now in order to find the y, I'm going to substitute the x is 3 into the linear equation, the line, to find the y. So if I plug in a 3 here, I get 3 plus 2 is 5, and y is 5, right there, okay? And then I plug in the negative 2 plus 2 is 0, and y is 0. So I found the y's that go with each x, but now I'm going to check them in my quadratic equation, because remember, a true solution has to solve both. So now I'm going to plug in my 3 here, and I get 9 minus 4 is 5, and that works. I'm going to plug in my negative 2 here, and negative 2 squared is 4. 4 minus 4 is 0, and they work. So my points are 3, 5, the x and the y put together, and negative 2, 0. And there we have it. Now the last problem in this section is x squared plus y squared is 416, and y is negative 5x. This one has got, actually this one is not a parabola, because parabolas, we know them by one variable being squared. This one is actually a circle. Okay, and then this one is a line, so we have a line going through a circle. Well, if we had a line going through a circle, we could have two solutions there too, couldn't we? We would have a solution where they crossed. So here, what we're going to do is I need to use substitution. So this was my original information here. On this one, I've got a y squared, but here I only have a y. What if I squared both sides? Remember, we can always square both whole sides of an equation. If I square both sides, I get y squared, and then negative 5x times negative 5x is positive 25x squared. So now I have y squared, which I can substitute back in here. So now I get this new equation down here. X squared comes down, y squared turns into 25x squared, and then I just bring down the 416. Now, do you see an equation that only has x squareds in it? So 1x squared plus 25x squared is going to be 26x squared. And on the next slide, we have 26x squared is 416. Okay, I ran out of room, so that's something that's coming up here. So 26x squared is 416. I divide both sides by 26, and I get x squared is 16, which means that x is plus or minus 4. So here's my x solution. Okay, so then I'm going to plug into my original equation here. I'm going to plug in the x is plus or minus 4. And when I do that, I'm going to end up with this one right here becoming 16. So 16 plus y squared is 416. Y is then going to be, y squared is 400, which I put right here. Y squared is 400. Y is 20. Now I get y is 20 and x is plus or minus 4. I need to check it though. Before I check it, I need to correct one mistake I made. I said y is 20, but when I take the square root of 400, I get plus or minus 20. So I have my x is plus or minus 4, and my y is plus or minus 20. But I can't leave it like that. I must get more specific. I must tell you which y goes with which x, which we'll do in a moment. So let's go back and look at our equations. We had this equation and this equation, and we came out with x is plus or minus 4, and y is plus or minus 20. So when we look at this equation, okay, so basically this one will work no matter whether we put plus or minus 20. Plus or minus 4, plus or minus 20, doesn't matter. But this one, it matters. So if I plug in a positive 4, I get out a negative 20. If I plug in a negative 4, I get out a positive 20. Therefore, my solutions are, here's your work. So here are our solutions here, 4, negative 20, and negative 4, 20. And so that would be where our circle and our line would intersect at those two spots. So let's recap here. We started with two equations, one that was a circle and one that was a line. And we're looking for the solution points where they intersect. we squared the linear equation to get this, which gave us this, which ended up giving us the 26x squared is 416. When I divided both sides by 26, I got x squared is 16, which gives me two answers, plus or minus 4. Then I took them back into the equation, and I found out that when I went up here, that my y was plus or minus 20, but I still needed to get more specific and put whichever one goes with which x. So I went through and I plugged into my linear equation. When I plugged in a 4, I got out a negative 20. When I plugged in a negative 4, I got out a positive 20. So this is my solution set. Never leave just a plus or minus 4 and a plus or minus 20. You have not specified the solutions yet. All right, well, we're done for today, and next time we will come back with higher order solutions, higher order systems and their solutions, and that will be part C. And this is Mrs. A, and may God bless your day.